In this video, we are going to learn some factors that will affect confidence interval. The factor of sample size. The margin of error decreases as the sample size increases. And the margin of error decrease will result in a narrower confidence interval. Overall, the larger the value of n, the narrower the confidence interval will be, because the confidence interval will be calculated as the point estimate plus or minus margin of error. That's why the margin of error decreases. The confidence interval will become narrower. Before we go deeper about what factors will affect the confidence interval, we have to answer a question first. What does it mean to have a 95% confidence interval? If we used the 95 confidence interval method over time to estimate many population proportions, then in the long run, about 95% of those intervals will give correct results. That is, containing the population proportion. Vice versa, in the long run, 5% of the time, the interval will not contain the population proportion. First, you have to pay attention how much narrower the interval estimates are for the large sample size. So the picture on the right side has a sample size of 1,000, and the picture on the left side has a sample size of 100. You should notice that the confidence interval on the right side are much narrower than the confidence interval in the left side. Besides, there's one more thing you need to pay attention to. The red confidence interval means the true parameter is now contained in the confidence interval. And in the long run, there are approximately 5% of a confidence interval that will not contain the true parameter. The true parameter here will be 0.5. Same for the confidence interval on the right side. In the long run, 5% of a confidence interval will not contain the true parameter. 95% is the most commonly used confidence level. To increase the chance of a correct inference, or saying having the interval contain the parameter value, we use a larger confidence level such as 0.99. We settle for a little less than perfect confidence, so we can estimate the parameter value more precisely. We must compromise between the desired margin of error and the desired confidence of a correct inference. As one gets better, the other one gets worse. Finally, as the level increases, the interval gets wider. I will explain in next 2 slides why the level increases, the interval gets wider. Compare confidence interval with different levels of confidence. Confidence interval on the left side has a sample size of 100, a 90% level of confidence. Confidence interval on the right side has a sample size of 100 and a 99% level of confidence. It is very obvious that confidence interval on the right side has wider lengths. Meanwhile, confidence interval on the right side has a fewer red bar or red confidence interval. Remember that the red confidence interval means the true parameter values are not contained in the confidence interval. Most of the time, we want a narrower confidence interval because the confidence interval that is too wide is not providing too much useful information. For example, I'm 100% sure that the P, the population proportion, is between 0 and 1. So the 100% level confidence interval will be 0 to 1. However, you cannot obtain any useful information from such interval. In the meanwhile, we want the confidence interval contain the true parameter values as much as possible. So that's why we must compromise between the desired margin of error and the desired confidence of a correct inference, as one gets better and the other gets worse. In this class, we will focus on the following most levels of confidence. Remember that the level of confidence will affect the z-score we use. If the confidence level is 0.9, then and we call this number error probability. To find the z-score corresponding to 0.9 confidence level, we can draw a normal curve, and this shaded area will be 0.9. Because the normal distribution is symmetric at the mean, so this transparent area will be 0.05. Again, we will use the normal table to find the area to the right that equals 0.05. We can find a corresponding z-score to this value. As you may have noticed, with the increase of confidence level, the z-score or z-critical value increases. And because the confidence interval is calculated in this way, the increase of z-score will result in a wider confidence interval. Again, because the confidence interval is calculated in this way, the increase of a sample size will result in the estimated standard error decrease. And we call it the margin of error decreases. Remember that the margin, this part, is margin of error. So the decrease of a standard error will result in the decrease of a margin of error. And the decrease of a margin of error will result in a narrower confidence interval. This is an example from a textbook. You can pause this video and read the question. From the problem, we know that the sample size is 2000. The p-hat is 0.83 from here, and the sample is randomly sampled. To calculate the margin of error, first, since we estimate at the 95% confidence interval, the z-score will be 1.96 and times the standard error, and the estimated standard error will be calculated in this way. And the margin of error will be z-score times the estimated standard error. From last slides, we have calculated the value of p-hat and the margin of error. Then it is straightforward to construct the 95% confidence interval. So we are 95% sure that the true population proportion of people receiving the flu shot but still developing the flu is between 0.37% and 0.86%. And yes, we can show that the fewer than 1% of all people vaccinated with the vaccine will develop the flu, because the upper limit of the confidence level interval is 0.86%, which is less than 1%. Another example from textbook. You can pause this video and read the question. It is straightforward to get the p-hat. The p-hat is the point estimate. Because we want to find the 99% confidence interval. That's why the z-score here, corresponding to 99% confidence level, is 2.58. And this number here is the estimated standard error. This number here is the estimated margin of error. And we can calculate the 99% confidence interval in this way. And this is the result we can get. This one is the result we can get. We are 99% confident that the true population proportion of a chicken breast that contains this chemical is between 58.61% and 72.39%. Can conclude that the proportion of chicken containing alkaloid E. coli exceeds 50%. Since our confidence interval is completely above the 50, the lower bound is higher than 50%. We can conclude that the proportion of the chicken containing E. coli exceeded 50%. Note that if the interval had any value less than 50%, then we could not make this claim. Without doing any calculation, explain whether the interval in part A would be wider or narrower than the 95% confidence interval for the population proportion. We need to remember the rule that the less confident we are, the narrower the interval will become. Remember that the level of confidence determines what the critical value is, and the lower the confidence level of confidence, the smaller the critical value will be. And the smaller the critical value, the less the margin of error.